Okay, today we're going to start binomial theorem. Before we do the binomial theorem, we need to review what's called a combination. You did this in geometry, but you'll see it more in statistics, but we do need it for our theorem here, so let's review how to use it. Here's the formula for combination. Combination was that thing when it was like, you have 10 numbers. How many different combinations of that 10 numbers can you make? So that's what this is doing. So let's review how to read this and type it in our calculator. So this means there's 7 options, but you're only choosing 5. 11 options, but you're choosing 0 of them. 13 options, and you're choosing all 13. This is another format of it. This is the format that we're gonna use. It just ignores the C. So you have 15, but you're choosing 3. You have 8, but you're choosing 6. Now in our calculator, and if you don't have a calculator, I'll try to find a combination calculator for you and link it in the folder. But you're going to go to probability and then where it says combinations. Now it gives you parentheses and you have to type in the 7,5. And it tells you 21. So there's 21 different combinations here. Do the same thing, 11, 0. We have 1. And go ahead to these last 3. This would be the 15, 3 and 8, 6. Go ahead and type it in, then we can check our answers. So you got 1. And again, this is that N, this is that R. So it's the 455, and you should have gotten 28. Okay, so now the actual binomial theorem. What you're doing is expanding a binomial. So say we had x plus y to any power. It's some kind, you're gonna be expanding it. If it's squared, that's easy. I wouldn't use the binomial theorem. But if it's something like to the 6th power, you don't want to sit there and write out x plus y, x plus y, x plus y, x plus y 6 times, and then FOIL, 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 distribute, 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 combine like terms, combine like terms, combine like terms. So the binomial theorem is a shortcut for that. Now, because you are adding, the way they wrote it is in the summation here. Now I'm going to kind of break down what this looks like using real numbers because I feel like it's easier to know what this is saying if you actually use numbers. So instead of a plus b to the nth power, let's look at a plus b to the 3rd power. And I'll use a small exponent just so you can kind of get the gist of it. So what this summation would look like, our n value is 3. That's the highest number we want to go. And then we'll do k equals 0 at the bottom. Okay, so our n is 3. K is our variable. That's what we're going to be plugging in, 0, 1, 2, all the way to 3. So then our first variable is a, and then 3 minus k, and then b to the k. All right, so now let's expand this. So remember, when you do summation, you start at 0 and you go all the way to 3. Here is our combination. This section is just these guys. So my first term would start with 3, and k, we're gonna start with 0. And then I'll do a, 3 minus 0 is 3. B, we're using 0 for k right now. Okay, now plus. Now I'm gonna go from 0 to 1. So it'll be 3 choosing 1. Now 3 minus 1 is 2, and I use the 1. Okay, now let's plug in a 2. So 3 minus 2 is 1, and I plugged in a 2. Last one I need to plug in, and remember I'm going all the way to 3. So now we're going to do 3 choose 3. 3 minus 3 is 0, and k, we just used 3. So that's how you would expand it, and then you would just type these different sections in your calculator and simplify. But let's go ahead and do that on the next problem. Where is my next problem? I found it. Okay, so x plus 2 squared. Again, we already know that this answer is x squared plus 4x plus 4, okay, because that's just FOILing. However, let's practice the binomial theorem with the smaller numbers so we can kind of get the hang of it. So kind of like what we just did with that A and B, but here is our A and here is our B. And then the biggest value that we want is 2. So I'm going to be doing from 0 to 2, x, and I'll do the 2 minus k, and then 2 is my next number right here, and that'll just be the k. Oh, sorry, let me go back. There's something I wanted you to note, a pattern I wanted you to notice before we continue. So if you notice, these combinations, the top number is always going to be whatever your exponent was. So our exponent was 3, so this top number is always 3. The bottom number always increases from 0 all the way to whatever that top number is, okay? So 3, 0, 3, 1, 3, 2, 3, 3. If it's 4, go 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, okay? Now the first term starts with the exponent and it increases, or sorry, decreases. So in 3, 2, 1, 0. But the second term starts at 0 and increases, 0, 1, 2, 3. That's gonna be the same for all of these problems. So doing this one, I'm gonna start with 2, 0. My first term is gonna take the biggest exponent times my second term, take the smallest exponent. Now I'm gonna go to 1. So 2, 1. The x decreases, the 2 increases. So 2 went down to 1, 0 went up to 1. And now my last one's gonna be 2, 2. So x goes 2, 1, 0, and the 2 goes 0, 1, 2. So now we just have to multiply that. So in my calculator, I'm gonna do this combination. So 2, 0. So that term is just 1. We got an x squared. Anything to the 0 power is just 1. Plus, now in your calculator, do 2, choose 1. You should get 2 times x to the first power is just x. 2 to the first power is just 2. Type this combination in your calculator and you should get 1. X to the 0 is 1, 2 squared is 4. Now just combine this. So that's x squared, that's 4x, and that's 4. So again, this was a long way to do this one, but the binomial theorem is going to be a shortcut for bigger exponents. For example, let's look at number 7. Okay, so I'm going to go ahead and get started because I know that this is going to be 4, 0, starting out with my exponent. My first term is 2x. Since I kind of have a double, I'm going to use parentheses. She gets the biggest exponent. My next one is negative 3. That negative carries with that number. And I get the 0. Okay? Plus, go to 4, 1. 2x decreases, so 4 goes down to 3. The negative 3 increases, so the 0 goes up to 1. Okay, I'm going to continue this. 4, 2. This decreases. This increases. Another thing to notice to kind of check your work is these two exponents should always add up to that top number. So 2 plus 2 is 4. 3 plus 1 is 4. 4 plus 0 is 4. Plus 4, 3. Last one is 4, 4. And now I'm going to use my calculator to multiply all of these sections together. So go ahead and pause this video so you can practice typing it in. Otherwise, I'm going to go ahead and write it down. Don't forget when you do 2x to the 4th power, it's 2 to the 4th power and x to the 4th power. So this would be 16x to the 4th. If you're typing in your calculator, you would just be typing in 2 to the 4th power because your calculator won't type in x to the 4th, sis. And And careful, don't forget your negatives. You need to keep those alive and well. Okay, again, pause the video if you're not where I'm at. But now I have each of these terms. And now I'm just gonna simplify them, kind of like I did up here. Now because this is a negative, this is gonna be minus instead of plus. And I'm just multiplying those numbers together. And there's our answer. So for this one, this was a lot shorter than foiling on all this, because what the binomial theorem skips is all the combined like term steps. So it's a lot easier to not make a mistake when you're trying to combine like terms and move things around. Okay, now the way that you're gonna see me ask questions, because I'm not gonna sit here and make you write all this out each time because I don't have time for that. I'm gonna ask you for a specific term in the equation. So I gave you a binomial, but I just want to know what is the seventh term. So what that would look like here is I would say, okay, here's the binomial, what's the third term? So then my answer would be 1, 2, 3. So my answer would be 216x squared. That's kind of what I'm asking, okay? But now for number 8, I don't want to sit here and write out that whole thing just to box the seventh term. I kind of want to be smart about it. Okay, so I know that this is going to start out at the 9, 0, and then go to 9, 1, and then go to 9, 2, right? That's how this works. So this is the term number 1, this is number 2, and this is number 3. If we want the seventh term, that doesn't mean the number 7 is on the bottom. Because we start at 0, it kind of throws things off. So the number in your combination is 1 less than the term. So if I want the seventh term, then that means there's going to be a 6 here. Okay. So now I need to figure out 3x is my first, 2y is my second. Okay, if you go back and look at that pattern, notice this bottom number always matches the second term. The bottom number matches the second term. The bottom number matches the second term. So this 6 is going to go on 2y. And then remember we talked about these two exponents have to add up to 9. So 6 plus what is 9? You guessed it, 3. And now we just have to solve this out in our calculator. So a combination of 9 choose 6 times 3 cubed times 2 to the 6th power. I'm going to type in all of that. And that's the number that I got. And it'll just be x to the 3rd, y to the 6th. Let's do another one. So I want the third term. The top number is 10, that exponent. Remember the term number, you put 1 less in your parentheses. So I'm gonna do 10 choose 2, 2x, and then negative 7y. She gets the bottom number, and then it has to add up to 10, so this will be 8. 10 choose 2 is 45. 2 to the 8th power is 256. Negative 7 squared is 49. But now I need to simplify that, so multiply all the numbers together. And then x to the 8th, y squared. So that's the third term if I were to expand this binomial. Okay, last way you're gonna see this is if I just ask for the coefficient. I'm telling you, here's the exponents. I just want to know the number in front. So because 6 is the second number, I know that 11 goes on top, 6 is going to go on bottom. The first one is 3x, the second one is negative 4y, And then it already told me my exponents, 5 and 6. Okay, so now to get that coefficient, I'm going to type this in my calculator. 11 choose 6 is 462. 3 to the 5th power is 2. Oh, it's only one time. I'm proud of myself. 243 x to the 5th. Negative 4 to the 6th power is 4096 y to the 6th. Now when I combine this, I don't care about x and y because I just want to find a. So I'm going to ignore x and y and just multiply my numbers together. So my coefficient is dyslexic, it's fine. 459,841,536 is the coefficient to that term. And that's binomial theorem. Phew!